This lesson is writing an equation from a graph. So we're going to be given pictures of graphs that look like this, and you now have the tools necessary to write a polynomial equation that will fit that graph. So the steps are going to be, number one, identify the zeros. We know that the zeros are where the graph crosses the x-axis. So I see one here at -3, there's one here at 1, and there's one here at 4. Those are the zeros. Okay? Step 2, let's put those into factors so that we can multiply them together. Number 1, x equals -3, so the factor must be x plus 3. X equals 1, so the factor must be x minus 1. And x equals 4, so the factor must be x minus 4. Okay? So this is just an exercise in taking it from the x equals into the x plus or the x minus. So those are my 3 factors. Now once I have my factors, I'm simply going to multiply them together. When you have 3 numbers, you're multiplying 2 at a time. It doesn't matter which 2. So I chose to multiply these 2 together, and I FOILed it, and I got x squared plus 3x minus 3, or x squared plus 2x minus 3. If you don't remember how to do that, then you need to go back and look at multiplying with the area model. Now I have that expression, which I'm going to multiply by the last factor, x minus 4, and I did that in sort of a little box here to keep track of it. And then I combined my like terms and got x to the third minus 2x squared minus 11x plus 12. This is the simplest form of a polynomial expression that models the graph that we just saw. Okay? There's one last step that we have to do with that. And let me show you what that is. We actually have to check to see, because if I take a look, I've sort of resketched my graph here. Technically, there are any number of polynomials that could look like my graph at its intercepts or at its zeros, but they might look very different in other places. Okay, so here's one, for instance, that goes way up here. I might have another one that just goes like this, right? They could have the same zeros but not be the same graph. So let me show you how you check that. I rewrote the equation here, and I said, what would the y-intercept be of this equation? If you remember, the y-intercept is where we plug 0 in for every x. 0, 0, 0, 12. So the y-intercept should be 12 in this equation I just wrote. It should cross the y-axis at 12. But take a look where it crosses the y-axis. At 3. Okay? So that's not quite the right equation, because this one's saying it would cross at 12 when I have a graph that crosses at 3. So the way we're going to resolve this problem is we're going to write what the graph says divided by what the equation says. And I get 1/4. So I must have taken a graph and shrunk it, okay, by that amount in order to get my equation to fit. So the way that I show that is I simply take that equation that I found before, put parentheses around it, and put a 1/4. Now my y-intercept is 1/4 of 12, or 3, just like my graph showed. Okay? Let me show you another one so we can make sure you understand. Example number 2, here I have a parabola. I see that my zeros are -3 and +2. So in order to write that equation, step 1, take those zeros and write them as factors. X plus 3, x minus 2. Next thing I'm going to do is multiply those 2 factors together, and I get x squared plus x minus 6. Okay? So this is the simplest quadratic expression that would model that graph right there. However, I have to check the y-intercept. My y-intercept is going to be -6, because if I put a 0 here and a 0 here, all that's left is -6. Okay? That's from the equation. But look at the graph. The graph shows a y-intercept of -10. So I'm going to put graph divided by equation, and I get -10 over -6, which simplifies to 5/3. So that means I must have taken and shrunk this graph, or in this case maybe grown this graph, by this number right here to make it so that I get a 10 instead of a 6. So I put 5/3 in front of this equation in parentheses, and that's my final answer. Okay? Are we about ready for you to try one? I think we are. Okay, here I have an equation. I have the roots, so why don't you take a look, jot this down in your notes, and see if you can come up with the equation for this specific polynomial function by yourself.